So I need a new logo sting. Logo sting at the beginning of my videos. It's kind of long and it has a little glitchy effect and all this. I just want something that's kind of quick. So I've been trying to think of a good idea of how to do this. And I want something that's kind of like makes sense for the kind of content that I create and the kind of things that I do. And since I primarily focus on diffusion models, I want to do something with that. So I could use traditional routes and try to like show some noise and things like that. But I thought it'd be cooler. What if I actually denoise an image to match this? So this is going to be my logo sting. This image shows up, but I want it to actually denoise to here. Like, so if you ever watched the denoising process when you're generating an image, you can see it starts out mostly noise and the image slowly forms. Well, it's hard to really simulate that accurately. And that's nowhere near as cool as what I want to try, which is we are going to train a LoRA on just this image. So that way I can actually generate something with, let's say, 50 steps, and I can do frame by frame all the way through those steps to actually show it denoising to my logo sting. So that's the goal, and that's what we're going to try to do today. And you've probably already seen the result if it worked for the intro. I don't know if it worked yet, but you do. Okay, so I'm going to pop over to RunPod. And on here, I'm going to use a 5090. I have preliminary support for this for the AI-Toolkit, but I'll show you guys how to use that currently. It'll be in the main repo. It's just, if you know anything about the 5090 or the whole Blackwell architecture, it's kind of a mess right now with all the dependencies. But I have a special build on here and I can show you how to use it if you want to use the 5090s. All right, first things first, you're going to want to find this image. It's Ostrus AI-Toolkit. You can search for it. AI-Toolkit. And yeah, this one should show up. It shows Ostrus AI-Toolkit latest, etc. This is the officially supported image. We need to edit a few things. One important thing is the password here. I have a special secret variable that you won't be able to see here, but you can just type your password in here. This is just to prevent people from logging in. So that way it's secure because this is exposed to the internet. The other thing I'm going to do, so for the 5090s, the latest image doesn't actually work. This is for anything before Blackwell, it'll work. But I'm having trouble getting the latest stuff because it's all beta and pre-release to get it to work right for every architecture. So this may not be necessary by the time you watch this, but for now, I'm going to put dev here. So this will pull the latest development branch, and that supports Blackwell architecture. Everything else here we can leave alone. That's all fine. Set those overrides. For this one, let's just call this logo. Okay, so we got a 5090 single GPU spinning up. Once we're here, we're ready to go. So we can come over here, click connect. And that's our HTTP service. This is the AI-Toolkit UI. You just click on that. It'll take you straight there. This is our password that we set. So no one can access your training run if you have that password set. I recommend you change it because it's password. But anyone just scrapes around ports and stuff, they might be able to find it. I don't know. Now remember, guys, we have an enormous data set here. Add images. Okay, and there's our huge data set. Single image, 1920 by 1080. So it's 1080p image. Okay, now we're going to go to training jobs. That's it. That's our whole data set. We don't going to caption it enough to do anything because we're just going to burn that image in. So that's the only thing it knows how to create. Let's create a new training job. All right, so we're just going to name this one Ostrus logo. Give it a trigger word of Ostrus. That's fine. I'm going to do it on Flex 1 Alpha. It's biased. We don't need inpainting and all that like you get with Flex 2. So let's just do Flex 1 Alpha. 32 rank. It's probably way more than enough, especially since we're burning in a single image. So for this, I'm not going to do sigmoid. Sigmoid's really good for people. I can do linear, and that's going to be where it evenly spaces out the time steps. That'll be good. We don't need EMA. For learning rate, we'll leave that. This is 1e -4. That's fine. Batch size, let's go ahead and bump this to like 5,000. I need to fix that. 5,000. Weight decay, 1e -4 is fine. Okay, all this looks great. So for our data set here, it's going to automatically inject the trigger word. So we can just leave that alone. All that's fine. But we do want, so it'll never upscale our images, right? So we go 1920 by 1080, and 1920 by 1080 doesn't actually fit properly because with Flux and Flux-based models, it actually gets it has to be divisible by 16 because it gets scaled down 16 times, 8 through the VA, and then it's packed down. So we can do the biggest one we want because it's never going to upscale the image. So this should be good enough. We don't need this many. So let's just do 1, 2, 3, 4, 5. I do want to keep one since we're burning it in. We'll keep this one with red hair, playing chess in a park. The bomb going off in the background. For this one, though, we'll just write ostrich. So that way we get to see if our trigger word is affecting it. And we get to see if it's going to burn through other prompts like this one. We got to be sure we change the width and height since we're want to be 1920 by 1080. Walk seed, that's all fine. All right, sample steps 25. I think we're all good here. So we're only going to do 5. 1, 2, 3, 4, 5. We're going to do linear time steps. Other than that, we haven't changed a whole lot here. And we're good. So let's go ahead and spin this up. Great job. We're doing this on a 5090. So let's start this. It's going to do the samples first, and then I won't spend too much time talking. We'll just let it run. So our first samples are in. These are the baselines. So yeah, this always does this with ostrich. It's, I don't know, whatever this weird thing is. I mean, some of it's worse because we're generating an image that's significantly larger than what the model's been trained for. But that's me. Some weird fossil sketch thing. All right, that's been training for a little bit. Let's check it out. Let's see how it is. So started out not doing too much. Just scroll to the bottom because that's where all the good stuff is. Okay. So it's not perfect, but it is definitely, close. I mean, very close. And I think this is doable. Now, the interesting thing I see here is that it didn't burn in past the woman with red hair playing chess in a park with the bomb going off in the background. I mean, it did change it some. It's not a realistic photo anymore. But really, it just kind of inherited the style a little bit, that flat style, which I think is kind of cool because it didn't, burn in the whole logo. I'm going to let this last line finish up with the samples, do a save, and then let's pop over to Comfy and let's write a ridiculous video generation script. Okay, so here we are in Comfy. I just have a real basic image generation setup here. We're using Flex 1 Alpha. We have our Flex logo, LoRA that we just trained. Ostrich, that's the trigger word. And then we just set everything up real simple here. We're going to do Flex conditioning 3.0. And the important part, 1920 by 1080. That is not 1080. It won't let me do 1080 because of Flux. Okay, whatever. We'll do that. All right. So we should be ready to go here. Let's give it a spin. Obviously, there's extra little thing there. It's not going to be 100% of the time, but that's fine. We can click generate a few times till we get something perfect. Now, this is still running out, and this happened kind of fast. So what I want here is to make it where it starts out as noise and actually starts denoising as it goes. So here's what we're going to do. I'm basically going to have to zoom way out, and we are just going to daisy chain every single step. So you may notice with the regular K sampler, you can do how much you want to denoise it, but what we want to do here is we want to do the advanced one. The advanced K sampler advanced. No, that's efficient. Just comfy core way. Okay. Fine. So we will hook this all up. Positive, positive, negative, negative, model, model. Now, I'm not going to make you guys sit through all this. I just want to give you an example. Okay, so we're going to do away with this. And now we're going to do this. So we're going to do it. Let's do it for 50 steps. With the advanced K sampler, the cool thing that we can do, one CFG. But the cool thing we can do here is we can do a start and end step, and we can do it with leftover noise and add noise enable. So the very first one, we want to enable adding noise, but we want to return with leftover noise. All right, so we don't want it to completely do that last step. And we can pick the start step and end step. So this is going to take us a while. We're going to do 50 of these, so we'll just do 50. And then that'll be your normal image generation. We run that through. That should be fine. Yeah, so that's what we get. Perfect. Okay, so what we can do though, since we're going to return with leftover noise, I can set this to 1. Right, so it's going to do step 0 to 1. And we run that. And you get pure noise, okay? And then so we can actually, do however much we want here. Okay, I think this is right. In fact, it's weird that the preview is giving us a full render. I didn't know it was actually doing that. But yeah, so here we have leftover noise. We can going up to step 50. So if we do it halfway is going to be like 25. Okay, 24, 25. Right, so that'll give us a 50% denoise. Just ignore this. I guess this is just going ahead and finishing it out. Okay, so yeah, it's going to give us half noise here. So what we're going to be able to do is we can basically generate it as we go, and we're going to have partially noised, and then it'll just be a denoising for all 50 steps, and until we get to the last step. So we can daisy chain this. I'll show you how this works. So we'll just copy it with everything, except now we're going to take the latent from that one. So we don't want to add noise on the second one or any of the other ones going forward. So the first one's the only one special because we have to add noise initially. Other than that, though, we are going to still return with leftover noise. But now we were at step 25. All right, here, let's change this to 10. Try step 10, and then we're going to end at step. Our last step is 20. You can see the last step up here. And then we're going to do step 10. So what it's going to do is denoise for 10 steps. And then we're going to come out, sample it. We're also going to run through this one. And we will sample at the last one just to show you how this is going to function. Right, so let's run that. And it's halfway done. So we have a halfway denoised image. It feeds it, continues it on, starting from halfway through the denoising process. And then this will finish it out. So you should have a clean image here. All right. Perfect. It's not an exact logo, but the cool thing is once we set up the workflow, we can just run it over and over. So I'm not going to make you guys watch that, but I'm going to set it up. It's going to take some time. You know what? Let's do a slow motion montage. I think that'll be best. Wait, we're done. That sucked. Sucked really bad. I mean, that was a couple lines of code, if that. All right. So we are done. This is our last node here. I'm just going to hook it to a reroute so I don't have to come down here and find it all the time. Perfect. Okay. This is our video node. I am sure I messed up something. But yeah, we'll see. Okay, so we hooked that in there. And we have our seed. So now we don't have to wait for the whole video to go if something went wrong. Let's go. Run it. Okay, well, I have absolutely no idea why it's not running these exit nodes. Probably because my workflow looks like this. There's a possibility I missed something. I'm seeing some stuff here. I don't know. There could be. Oh, there it is. Jeez. Let's make sure there's not any more of those. Okay, runs through, runs through, runs through. Okay, I think that's good. Let's see what happens. Okay, I think I froze something. I'm gonna try it again. Just restarted Comfy. So let's try that now. We're gonna do it with the video combined VHS node. This would be significantly faster if I just did it with code. It would have taken me less time. But I enjoy having this crazy workflow because then if I want to change stuff, I can share this. And plus, I mean, just look at this. I mean, that just looks cool. Right? Comfy's simple. You know, you just show this to someone and be like, yeah, it's simple. You just hook this all up. It's no big deal. But it also shows you can do relatively complicated stuff in here. It's such a powerful tool. Nice. I feel like, is that right? Is it doing a different order? It almost feels like it's doing a weird order at the start. Okay, here's going the top, 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 top. Comes out. Yep, different order. Okay. It's in the top, 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 top. Okay, perfect. So now, since we did that, we don't have to like redo the whole seed because we took the time to make the seed value. And that's the denoising process. It still seems a little weird at the beginning, but I think it's fine. Okay. So now, unfortunately, seed 42 doesn't work. So we are going to do 43. And we're just going to run this a few times to find when the logo's the way I like it. I keep having to go back and check my logo because I don't remember which arms are longer. But this is exactly what I was going for. It's a nice, clean, smooth transition. And it does more than just the logo sting. I mean, you actually get to see here, this is the denoising process or flow matching, as this model is doing flow matching. Normally with denoising, it'd be a little more chaotic, but that's the thing about flow matching. It's a nice flow straight from noise to signal. I'm going to run it a few more times. I really want to see if I can get maybe a little closer to my actual logo because this is not quite perfect, but it's close enough. I'll put all this stuff in the description link so you can download this workflow. I mean, because look at this workflow. If anyone wants to do this, I don't want you to have to do this. The only thing you'll have to change is, your size if you don't want to do one this size. But other than that, you can pretty much just drop it in place and let it go, and it'll sit here and run. Be sure to like and subscribe to my YouTube. I do open source full time, so if you use AI-Toolkit or use any of my models and you're thinking about supporting me in some way, I'll post a link to how you can support me. Just go to oshers.com/support. All right, I hope you guys enjoyed, and I'll see you next time.